Hi everyone, this is the MakeHaven badging video for the table saw. I'm sorry that it's a little longer, but this is an important tool and there's a lot going on, so let's get started. So the table saw is used in general for ripping, and what that means is when we look at a piece of wood that came from a tree, which is to say not the plywoods and OSBs and other weird things, going with the grain of the tree. So if we look at this piece of wood, we can see where in the tree it came from. So you can see that the middle of the tree was somewhere around here, and these are the rings in the tree, and this board sat in the tree like this, which means that ripping is cutting this way along the piece of wood. And in general, that's what the table saw is for. You can, which we'll get to later, do cross cuts on it. And as long as we're talking about it, this is called resawing. And this is generally on the bandsaw, though there are some exceptions. So the table saw in general is for ripping, so that's what we're going to focus on. The caveat to that is that while on this piece of wood, ripping goes with the grain, there are some cases where ripping, in fact, refers to going in the direction of the long dimension of the piece of wood. So on this piece of plywood, for example, here the grain is going this way, but there are a lot of layers of wood in here with the grain going the other direction. So we're still going to call it ripping when we go in the long direction of this piece of wood, even though in some of those plies, some of the layers of pieces of wood here, we're not actually going with the grain. So that's what ripping means, and that's pretty important. And then just for reference, this piece of material is called OSB, Oriented Strand Board, and it's another example of a material where the direction doesn't necessarily line up with what the words that we're using. So just as a counterexample. So that's what the table saw is for. And then just as a note, this is called a Sawstop table saw, that's the brand, and what makes it special is that if your finger or some body part were to contact the blade, it would stop very rapidly. That doesn't mean you won't get hurt, but you hopefully wouldn't lose that whole digit. So bear that in mind. That does not at all mean that we're gonna use this tool as though it were anything less than a very dangerous table saw, because it still is. The first thing we want to make sure is that the top is relatively clean, and it's hopefully clean because the person before us left it that way, and that's how we're going to leave it for the next person. The reason that's important is because if there was sawdust on here, our piece isn't going to be flat, and we're not going to get a good cut. So we want to start in this condition, and then we're going to start by going inside of the table saw. Before we do that, we want to make sure that it's off. So you can look here and see that there are no lights, which means that we haven't swiped our card and turned it on, so the machine is off. And then we're gonna open up the inside. The way we do that is by lifting up on this little tab here, and then we can pull the table insert, this red thing, right out. Now we can see inside the tool. So there are a few things we're gonna look at. We're gonna look at the blade and the cartridge, which is way down there. What we're gonna do first is just see how to take the blade out, because the blade is sort of the central part of the tool, so it's important to know how to take it out and realize what it's doing. So the tools to do that are over here on the left side of the table saw. There are 2 wrenches. They're the same, but they have different ends. The open end goes on the inside of the blade, right down there. And then the closed end goes on the other side. And then we're just gonna use the wrenches to take that nut off, just like that. And then the rest you can do by hand. So we're just gonna spin this off, and we're gonna take care not to drop the nut and washer down. If you do, it's not a big problem. I'll show you how you would retrieve it. Frankly, they do get dropped fairly often. So take those off, we'll take the blade out. Something I'm gonna mention now is that our blades have carbide teeth. Carbide is very hard and brittle, which means if it were to hit against this cast iron table, it would break the teeth. So take care to be gentle with it. So this is a combination blade, which it used to say here before it got rubbed off. Combination means that this blade is good both at ripping and cross-cutting, so it can do both of those. It also has a pretty average number of teeth. So here you can see it has maybe 2 or 3 teeth per inch, or TPI, which is how we measure blades. And that's sort of in the middle. So we'll look later at blades that have a lot of very fine teeth or only a very few teeth. And those are for special purposes. In general, we'll use this one. So we're gonna put this one back in. And you want to make sure that as this blade spins, it's spinning towards you, so the teeth are facing towards you. which means that the text is on the left side. So we're gonna put it right back in. But before we do that, we're gonna look at the two other things down here. One is this writhing knife, which I'm just gonna move out of the way so that we can see the cartridge underneath. I just lifted that gray handle and slid that out. And now down there, you can see a cartridge. I'm gonna lift up, and hopefully you can see on that little red handle, maybe, you'll be able to see it in 1 second. So there's this little red key, that comes out, and then this cartridge comes out. It takes a little finagling. And this is the cartridge that gets launched up into the blade if you were to contact it. So this is obviously pretty important. The only reasons you would take it out is if you're switching to a dado stack or if this is deployed. So if you're using the table saw and it deployed for some reason, either because your finger touched it or because you're using a very wet piece of wood or piece of metal or something that it thought was flesh touched it, then this gets launched up into the blade, which destroys the blade and this. So it's pretty expensive. You obviously don't want that to happen. If it does happen, there's an extra cartridge on this side of the table that gets launched up into the blade. In addition to that happening, it will also drop the whole blade assembly down into the table. So what you'll have to do is reach down and lift the whole assembly back up. Now, if you don't feel comfortable doing that, that's absolutely fine. Just post on Slack and put a out of order sheet, which is right up on the wall, onto the table so that everyone knows that it is not safe to be used until the brake is replaced. So we're just gonna put the brake right back in. It takes a little bit of finesse to align it. You're just trying to align that big hole and that little hole down on the pins. And it's right back on there. And then this red key goes right back in. Okay, and now that's back in there. And then the writhing knife also drops back in. And ta-da, and now the blade. So as I mentioned, we're gonna make sure the teeth are facing this way. We're gonna take care not to hit it against the table. And right back on. This washer goes back on. It's important that the cupped inside face of that washer is sitting on the blade, so that the concave surface is sitting against the blade. Then the nut goes on. And we're just gonna spin that. And then as we tighten it, you don't need to crank down crazy hard. It just needs to be snug. Just like that, it's good enough. We'll hang these back, and now we'll look at the side of the table to see the other kinds of blades. The extra blades over here, there's the combination blade that we were looking at. That's the most versatile blade. Then this is the fine tooth blade that's good for leaving a smoother finish. It'll cut more slowly, but it will leave a very smooth finish. It's also good for cutting things like plexiglass or very thin plywood. So this could be what you're looking for. And the other end of the spectrum is the ripping blade. The ripping blade will leave a pretty rough finish, but it'll cut very quickly. It can cut very thick woods and very dense woods. So if you're ripping long pieces of oak, for example, it would take you a long time on this blade, but with this one, it'll go through relatively quickly. If you're cutting with this blade and you can start to hear that the motor is bogging down, that it's struggling to get through the piece of wood, then that's a good indication to try the ripping blade. So now that we've looked at those various kinds of blades, we are going to put the table insert back in. So when you're putting the table insert in, it's important to slide it in and then drop it down from the front. Sometimes what happens is people plop it down on top and it's not flush. So it's important to make sure that it's flush when you set it in. Something else is that if you were to drop the nut and washer down while you're replacing it, they would roll down this hose, and then you could just undo these clasps and shake it out, and then you would have the nut and washer would fall right out the bottom. So not that big of a deal if you were to do it. So next we're going to I just want to mention quickly that on the blade, it has those carbide teeth, and if they were to chip off on something, it's effectively a bullet. And that's just another reason why it's important to be wearing safety glasses, even if you're not the one operating a tool. If you're just in the vicinity, if you're in the wood shop, we make sure that you're always wearing safety glasses, because a lot of the tools have carbide teeth that are very dangerous when they are spinning. So now we're just going to look at some of the other accessories on the tool. So this is called the rip fence. The rip fence we use, as you may have guessed, for ripping. And the way it works is it slides when the handle's up, and then when you push that red handle down, it's locked into place. And we use this when we're ripping in this direction. This shows us, excuse me, how big our cut is going to be. So right now it's at 18¼ inches. And what that means is that the distance between this side of the fence and this side of the blade is 18¼ inches. And that's, in general, the important dimension for us. So that's what the rip fence is for. These are stock guides, so we'll get into exactly how to use them later, but they're an important tool for ripping. We're going to look quickly at the angle adjustment. So if you wanted to change the angle of the blade, you turn this, and it shows you approximately what the angle is here. And then this shows you the height of the blade. So you raise this up and down, and it changes the height. So you want to raise the blade up and down, that's what that's for. And on this wall, there are 3 tools that we're going to look at. The first tool is probably the most commonly used one for this purpose. It's called a tri-square, and it's just set to 90 degrees. So when you want to make sure that that blade is set back to exactly 90 degrees, you can hold it up to the blade. The other one is an angle meter, which we'll look at. And then the last is the height gauge. So I just wanted to show you where they are on the wall so you can find them. We can see first, so this has magnets on it. So we'll start by having it flat, and it says it's at, we'll just tell it 0 because that's 0 degrees. And then we'll stick it right to the side of the blade. It'll tell us what angle our tool is at. And so that's a convenient way of getting a much more precise measurement on the angle of our blade. And then when we're ready to set it back to 0, and we want to make sure it's exactly at 0, we'll turn this and use this tri-square. When you're using the tri-square, you want to make sure that the blade of the square is not sitting on a tooth, but in between the tooth. And make sure you can't see any light between the blade and the tri-square to make sure that it's totally flat. If it isn't, then you just adjust the angle until it is. The last tool is the height gauge. So the table saw itself doesn't tell you how high the blade is, which is why we have this. So you just turn it on. It also has magnets to hold it down. When it's all the way down, it should read 0. And then when you put it over the blade, try to find the highest point. And that looks like the highest point right there. And that's 2.414 inches. So that's just a good way of finding out what the height is precisely, if that's important to you. So those are some of the accessories, and just make sure to put them away when you're done. So sometimes you have a really long piece of wood and you need support at the in-feed or at the out-feed. So that's what these are for. These rollers are just set them up at the right height and position for you. There's one here, and the others live against the wall over here. So those are the rollers. When we're ripping, the blade is trying to follow the grain of the wood. And so imagine if you're driving in the snow, which is maybe an appropriate reference for New England. I'm sorry if you don't live here. The tires in your car want to follow tracks that are already in the snow. And it's similar here. The blade is trying to find the path of least resistance when you're cutting. So you may be cutting, and then all of a sudden, the blade wants to go slightly over, and it moves on you. When you're cross-cutting, that's less of an issue, because there are no tracks for the blade to follow. So that's just to say that when you're ripping, you need to make sure to hold on very firmly, make sure the piece is well secured, so it doesn't move on you. Another thing to watch for when you're cutting, especially in softwoods, are these knots. So these knots here and here where branches came out of the tree, and they're much harder than the rest of the wood. You can see here that someone was able to gouge up the wood very easily, but they'd be much harder here. When the blade hits there, it's going to get slowed down because it's harder. So you just need to be prepared for that and have that in the back of your mind while you're cutting. And when you're cutting, it's important to think of this blade like a ramp, because it is. Even though it's spinning, it's at this angle. And especially when it's at a lower angle, what can happen is the piece of wood can be lifted up. So it's important to make sure that the piece of wood sits flat on the table. Some of the consequences of it not sitting flat or of the piece moving, like I mentioned before, are kickback. So kickback happens when you're cutting the piece of wood, and then for some reason it moves. And when it moves, it can bite onto the back of the teeth and then shoot back at you. And kickback is very dangerous. It doesn't happen super frequently, but when it does, it can be very painful. So it's the things that we do to make sure that we mitigate kickback are using this riving knife. The riving knife sits right in the groove that the blade cut so that it doesn't let it go side to side. We use push sticks to make sure that the piece is held firmly down on the table, push through, and then the last thing we use are these stock guides. So the way the stock guides work is we take this surface and it rests on the piece of wood, so not the wheel is important. We use the black piece and then tighten down on the top. In terms of position this way, you can slide them wherever is useful for you. We're going to do the same thing on the back one. And tighten this down, make sure that these are tight. And now what's going to happen is when we slide this piece of wood through, the wheels are going to push down on the piece of wood so it stays flat, so that's important. They only roll forwards, so when it tries to roll backwards, if it were to try to kick back at you, it wouldn't let it. And the last piece, which is really pretty fantastic, is these wheels are angled inwards a little bit. And you might have to look at it in person to see, but they have a slight inwards angle. And what that does is it pushes the piece of wood right up against the fence. So that means that if you have a big long piece of wood, you can push it through, and whereas before you might need rollers or another person, here you can comfortably push it through and know that the stock guides are going to hold it right against the fence and give you a nice crisp cut. So that's super valuable. So when you're cutting, it's important to mark the piece of wood, especially when you're getting started, so you know exactly where it's going to cut. Let's say you want your piece to be cut at 4 inches. If you were to put the blade right in the middle of 4 inches, then you're going to lose a little bit because the blade has kerf. Kerf is the width of the blade, and if you cut on your line, half of that kerf is going to cut into your 4 inches that you wanted. So it's important to bear in mind where you're going to put that kerf, which is why normally we put the piece that we want, the part that we're keeping, on the inside of the blade, and the part that we don't want on the outside. That's called the waist. One caveat to that, however, is it's very important that the wider piece of your cut is on the inside. So here, if we say this piece of wood is 5 inches wide and we want 4 inches of it, that's easy. But if we wanted 1 inch of it, we would need to do a little math to make sure that the 1 inch is on the outside. The reason for that is if you're going through and you had the skinny piece on the inside, it's very easy to twist around the blade and have it bind in between the blade and the fence and shoot back at you. So it's important to have the wider piece in between the fence and the blade. In terms of the height of the blade, I'm just going to lift this so we can get this out. We want the flutes to be exposed, so the gullets is the word for the space in between the teeth, so that the sawdust can escape. But we also want it so that mostly it's teeth being in contact with the wood. Right now we have a whole lot of just metal pushing up against the side of our piece of wood. So I'm going to bring the blade down a little bit, more like there. So now the sawdust can escape from the top, but it's also, we have a lot of tooth in contact with the wood instead of just the side of the metal. So that's how we set the height. In terms of when we're putting the wood through, you want to be in what we call a pool player stance. So that means your body is perpendicular to the table. So if it were to shoot back, it goes past you. Your left hand is planted right on the cast iron. So your left hand is not moving, assuming you're right-handed. If you're left-handed, then this whole situation could flip around for you. Assuming you're right-handed, or you're comfortable cutting this way, your left hand is going to stay planted, and it's holding down on the piece of wood. So I'm just going to move this out of the way. So your left hand is staying planted here, it's holding down and pushing into the fence. And your right hand is pushing. So this is uncomfortable for a lot of people. People tend to spider their hands forward or inch their hands forward, and we're just going to put the kibosh on that. Your hand stays absolutely firmly fixed. You're not going to get a splinter. If you do, that's a small price to pay. And you're just pushing down and inwards. Sometimes what happens, as I mentioned, is it acts like a ramp and lifts the piece of wood up. The fix for that is lifting up with your right hand and down with your left, so the wood stays planted on the table. Now, when you use the stock guides, that can help take the place of your left hand. So as I mentioned, you can have a piece of wood and be all the way back here and not need your left hand on the table when you're using these stock guides. But when you're not, for whatever reason, maybe it's a really small piece of wood and it's too thin for these stock guides, then your left hand stays absolutely fixed. That's really important. And then when your hands meet, so you're pushing through, and then your hands meet, you grab the push stick, which you will have conveniently put right next to you, and that push stick continues and finishes the cut. What you want to make sure is that when you push all the way through, or else with the wood sitting right next to the blade, it might get marred up or burned. So you're going to push all the way through, and then your cut is finished. If your piece of wood is really wide, if you're cutting a piece of wood like this, then you don't need to use a push stick. I think like a good rule of thumb is if the piece of wood is thinner than 6 inches, you want to use a push stick. This one's wider, so you could use just your hand, or if you feel more comfortable, by all means use the push stick. At no time should your hands get into the red area when you're cutting. That should be definitely out of bounds. It's important to make sure that your piece of wood isn't touching the blade when you start. So when you turn the tool on and it starts spinning, you want to make sure that your piece of wood is away from the blade so it has time to get spinning, and then you start pushing. If you were to have it up against here and then you start, it would get bogged down or throw the piece at you or something equally unpleasant. In terms of how quickly you should push, you don't want to push so hard that you're overburdening the material or the motor. You can hear it as it starts to bog down. But you also don't want to go so slowly that the blade is just sitting next to the wood burning it. And that's something you just get a feel for. So you just get comfortable with how quickly you should be pushing based on the smell and how the motor sounds. Something else is that this blade, even though the blade doesn't weigh very much, is connected to a motor that has a whole bunch of mass. So even after you've stopped the blade, turned the motor off, and it's still coasting down, it has a lot of momentum, which means you need to wait until that blade is totally stopped before reaching over it or getting anywhere near it. It may look like if you were to touch it, it wouldn't be that big of a deal, but it would still very much cut through you. So bear that in mind, that you want to make sure any necklaces, sleeves, anything is totally out of the way, because in this tool you're occasionally going over the blade with your body, which is a little scary. So now we're going to look at making a cut. So the first things that we want to make sure, obviously always wearing eye protection. In terms of ear protection, that's kind of at your discretion. Maybe if you're doing this for long periods, I think I would use ear protection. For short periods, it's not that loud. It's certainly less loud than the compound sliding miter saw, sliding compound miter saw. So that's at your discretion. It's up on the wall. I would say that if it starts to feel like it's getting dusty, then put on a respirator. Otherwise, in general, the dust collection does a pretty good job, but eye protection all the time. In terms of turning on the tool, you're going to use your card, and the card gets scanned back here. You scan, you can hear it blink, you can hear it beep and see it blink, and then push the green button, and the green light turns on. So now the tool will stay on as long as you're using it. The other thing we want to do is make sure that this gate is open. So this is the vacuum. It's very important that this is open. If it's not, then the machine will get full of dust and stop working. So make sure this is open, and any of the other tools connected to this system that aren't being used are closed. So this planer is not being used, so the gate is closed, which is good. Over here is the floor sweep. Floor sweep is closed. And last but not least, the jointer is also closed. So now that we have confirmed that these are closed, look at the last source of dust collection, which is this guy. So this can be used if you're cutting a wider piece of wood, like this piece of OSB we were looking at. It just slides right over the blade and then drops down. And then you would open this little gate so that it can vacuum up. In that situation, it's great. If you're cutting something skinny, then it's going to be getting in the way. So if it's skinny, you can just push it out of the way. After we scan the card, we can look down here and see that this light is green. It takes a little while. It takes maybe 20 seconds to turn green, and the saw won't turn on until it is green. So while it's blinking, if you try to pull the switch, it won't turn on. Also, after you turn it off, after you're done cutting, if let's say you realize 2 seconds later you want to cut again and you try to pull it, it won't, because it'll still be blinking green. So you need to make sure to wait until it's fully stopped, and then it'll be green again so you can turn it back on. Occasionally, because this is a somewhat more complicated piece of electronics than most table saws, it'll be blinking weird lights. And what you can do is look at this little cheat sheet right on the side here, and this will tell you what those lights might mean. It might be something simple, like you didn't do a good enough job of putting the brake cartridge back in, or it might be more complicated, in which case just post on Slack and put a sheet on the table so that someone, a staff person, knows to fix it. One other quick note is that we're just going to leave this switch on all the time. Unless you feel compelled to turn it off, we can just leave it on and use the card system to turn the tool on and off, or to give it power. And then the last thing here is this key. And so what this is for putting the tool into bypass mode. So that means it will bypass the Sawstop system. So if you know you're cutting a piece of wood that's wet or has moss on it or might set off the system, then what you do is you turn this key to the right. So we'll turn it to the right. It's gonna blink red, and then we're gonna turn it on. It blinks red again and green, and now while it's blinking green, it's in bypass mode. So we'll turn it off, and you can hear that the dust collection system turns on automatically, and then turned off automatically. When it's blinking green, it's in bypass mode, so it's a normal table saw that will totally cut you. So be wary when you're using that, but do use it if you're cutting something like a really wet piece of wood or plexiglass, thing that could build up charge, to make sure that it doesn't accidentally deploy the system. When you're doing cuts like that, you need to turn the key every time to put it back into bypass mode. So that's important to bear in mind. So now we're gonna do a rip cut. So the tool has the green light, it's good to go. First, we're gonna just do a traditional cut without using the stock guide, so I'm gonna move these out of the way. I'm gonna set the fence so it's about 5 inches, so it'll just take a little bit off. I have my push stick right over here. My body is perpendicular to the tool, left hand is planted on the table, and my right hand is here to push. I'm gonna pull the switch to turn it on. As you may have seen, I pulled the switch to turn it on, and then I just nudged it with my leg to turn it off. So then it turned off, without me even needing to take my eyes or hands off the table. So that's a nice way, it's called a paddle switch, of just making sure that your attention stays focused on the table. So now we're gonna do a cut with these stock guides, and just dropping them down like we showed before. There we go. And I'm just gonna slide the fence over a little bit. You can move a piece of wood away from the blade. And as you can see, I didn't even need to use my left hand. It left a super nice cut. So that's the benefit of using the stock guides. We also have a feather board, which is a more traditional tool. It has magnets that stick it down to the top of the table. And if there was a case where the stock guides didn't work well for you, you can use the feather board. And that's another good way of applying lateral sideways force. It just doesn't apply downwards force. I'll put this back. So that's ripping, and now we'll look at cross-cutting, and we'll be good to go. So for cross-cutting, we do not use the rip fence. The rip fence is just for ripping. So we'll move this out of the way. And there are a few options for cross-cutting. For cross-cutting, we can use the miter gauge. This is good especially for angles. So when you're cross-cutting, in general, the tool you're going to use is the sliding compound miter saw. That's the default tool. So the only reason you use the table saw is if there is some reason you can't use that. Just bearing that in mind, that's the more stable tool for the task. So here, we can set the angle to whatever we want just by loosening this and then tightening it down on an angle. Our hand closer to the blade is on this red handle. The one farther away is holding on. If we were to flip to this side, our hands would flip, so that the hand closer to the blade would be on the handle, the one farther away would be holding on. Then I'll just turn it on. Because there's less likelihood of the blade catching, we don't need to be quite as firm as when we're ripping. Here we're okay with just holding and pushing through. Bear in mind though that if you were to use the rip fence, the reason we don't want to do that is then there's a very good chance of binding. So if you were between here and the blade, you could get pinched and throw back at you. So let's say you're doing a whole bunch of cuts and you wanted to make sure that they're the same length. So you're tempted to use this fence to make sure, say they're all at 15 inches. What you can do is put a small piece of wood here and maybe clamp it on. And so that will tell you that it's exactly at your measurement consistently if you're doing 20 cuts. And then once it passes and it's getting to the blade, then it will pass beyond this piece of wood, if that makes sense. You'd clamp this on here with a clamp, and then it won't be bound because it's no longer touching the fence. So that's just a trick you can use so that you can use the rip fence, but it won't bind. The other tools we can use when we're cross-cutting are sleds. So sleds are a subset of jigs. Jigs we use in the wood shop anytime where we don't have the perfect tool for what we're trying to do, and so you just make it up. So you can see that all of these are jigs that are made by members to solve a certain problem. Probably the most common one used here is this cross-cut sled. So let's say you just made a cutting board with a whole bunch of slots, and it's too wide for our chop saw. On this tool, on the cross-cut sled, it has these rails on the bottom that sit right in these grooves on the table. And when we have the piece of wood on here, we're just going to hold it on. You will notice that you'll need to raise the blade up because right now it won't go through our piece of wood anymore. So it'll be important to raise the blade up a little bit. All right, so that looks like enough. And then the most important piece is making sure that on this side, your thumbs are not anywhere near this slot where the blade comes out. So if the blade comes out, you don't want your fingers. So if you're holding something like this, you just make sure your fingers aren't anywhere in that area. So we can pretend that we're making a little slot for our piece of wood, so we can make some kind of joint. So I'll turn the blade on. That's an example of how you might use the crosscut sled to make what could be a finger joint. And when you're done using the table saw, we just want to make sure to put all the accessories away, to throw out any scraps, and then to vacuum up on top and all around the table saw, just to make sure that it's clean and all set for the next person. Also, the sawdust sitting on the cast iron can cause it to rust, which is another important reason to keep it clean. Thanks for watching.